Good evening and welcome everyone. Good evening. Welcome to Cat Ninjas. So we are continuing our journey with geometry. So today we'll try and see some of the core elements of quadrilateral. We'll try and spend some time, especially on quadrilaterals today. But before I get started, so we are into a big month, that is the month of November. I wish all of you the best of the months in the year. So because we are action-packed month, right? So we are into action-packed month. I'm sure it would be pretty encouraging to all of us. So as we progress towards the exams. All right. So here we go. On that note, so we will kind of look into the lecture. Before I get on to the lecture, let me quickly introduce myself. So I am Belvi Srinivas. I've been working in the test prep industry for the last 14 years. That's since 2007. And yes, I worked in various capacities, as most of you kind of already aware of. And yes, I worked both on the management side as well as on the training side. And when it comes to training, I did train the students in the areas of QA, TI, and LR most of the time. But then, yes, I do counseling in all the areas with respect to the B schools, the testing areas, all of which. That's briefly about me. And if you are looking at short counseling or you are looking at brief interactions, you can join this particular Telegram group. So I'd be more than happy to welcome you onto the Telegram group. And there are not only there are many active students on the Telegram group who will certainly help you in gearing up to address your concerns or putting forth some of their views. And wherever it is required, I will also chip in and we can work together. Yeah, good evening, Chinmay. Good evening, Isha. Good evening, Keval. Yeah, I'm guessing that audio, video, all is clear. So before we get on to the lecture, so as I told you, we'll be discussing a little bit about the quadrilaterals today. That's the whole idea. We'll spend some time on quadrilaterals before we mix and match the rest of the issues, right? Yeah. Yeah, good evening, Mukesh. Good evening, Srishti. Glad to have you guys here. Glad to have you guys here. Firstly, let me wish you the best of the month, November, to all of you because it's an action-packed month, right? So, as you join in, guys, my best wishes for November. My best wishes go with you guys because it's a big month. I know that this can transform some portions of your life. Those are appearing for CAT 21. Big month, nevertheless. Okay, let's not big month. We'll approach in the right fashion. Here we go, and here are some of the courses that are that are about to be launched during the eve of Diwali. So one of them is meant for OMET 22 or CAT 22, and one of them is specially targeted at IIFT. Yeah, on 30th, that's just about a couple of days back, there is an NMAT expert batch which has commenced. So some of the finest educators are coming out with this particular study. That's a batch. You can kind of try and look into these particular batches. But yes, to be a part of these particular batches, you might have to go for a subscription. Either it could be a plus subscription or it can be a iconic subscription. CAT 21 students advised is about 6 months. There are 3 months packs also available, but then yes, you can take a look. CAT 22 or 23 students can go for a year or year and a half or two kind of subscriptions. All these subscriptions are at a very pretty nominal price on which you can get 10% discount whenever you use any of the educator code, including my code. That's about the plus. And when it comes to iconic, yes, you do get 1:1 interactions. You can fix that appointment with the educators of your choice. So if you're looking at the 6 months, you get 25 one-to-one interactions, and here you get 50 one-to-one interactions, and in 24, I guess about 100 one-to-one interactions. These are the number of one-to-one interactions you get in this specified time. So one-to-one interactions, it could be with respect to your strategies, it can be with respect to preparations of the how to preparation prep calendar, or it could be with respect to your B school guidance, it could be with respect to validation of your application forms for the B schools. So many things. You can set up 25 interactions if you go for a 6 months package, and the numbers double based on the duration. The kind of number of interactions can double, which you can set up with your educators. Yeah, and all this comes at some premium price, it appears with respect to the plus, it appears little premium. Yes, on this as well you get 10% discount whenever you use any of the educator code. Yeah, that's pretty much. And there is a Diwali offer, those who are looking at the Diwali offer on some of these subscription plans. If you buy an annual plan, you get 2 months free. You buy 2 years plan, you get about 2 months free. This is one of the offers for Diwali. That brings us to the closure of the discussion. Yeah, all right. Keval is wishing the best wishes of Diwali Eve. Yeah, so same here, same here, same here to everybody. My wishes to you guys as well. Yep, so we are into a big month. Good evening, Ashutosh, Neha, Muhammad is here. Akunji, after a long time, glad to have you here. Good evening, Rishabh. Great, guys. So anybody else here? Anybody else here? You can exchange your greetings before we get on to the lectures on quadrilateral. Go ahead. So let me know the names. I could see from Chinmay to Isha to Keval to Mukesh, Rishti, and till Rishabh. Anybody else who would like to make some noise out here? Let me know. Quickly put in your exchange your greetings. Say hi, Preet. Yeah, right. Preet is here. You already put the text, Preet. Anybody else here? Anybody else here who are familiar to us? Sumit is here. Okay, good. Okay, so what we'll do today is we'll spend a little bit of time. Guys, it's a big month, big month. Are your plans in set or are your plans set before we get on to the discussion? You made a plan for November, kind of at least for the 2 weeks in your diary or on your Excel sheet, whatever the kind of planner that you follow. Right? If not, tonight you guys have to make it. Don't let it loose. Don't let it loose. Good evening, Marshall. Good evening, Ayan. Yeah, I'm asking about, have you made a kind of a plan for this particular month? Yeah, whatever it is. You guys have to have some plan in place for at least next 2 weeks, 10 days to 2 weeks. Yeah, why only 4, 5 of you are saying that you guys have a plan? Others are clueless what to do. No, Sumit, just study will not help. Just study will not help. It should be planned study. Just study will not help. Such things will not help. Don't let it loose. Be in control. My point is be in control. Don't let things loose. Letting things loose, you will get loose scores only. Right? That's what happens there. Okay, somebody of the opinion that hey, I go with the wind. No, you don't go with the wind. You control the wind. It's difficult to control, but control it. You got to control it. You have to control using your radar. You have to control your ship. Very important. Yeah, not just mocks, Mohammed, not just mocks. I think I made one of the videos the other day. There are 3 parameters that you may have to consider. I'm sure you are following certain guidelines. Don't worry, Mukesh. You go with 1 day at a time, make the plan and go 1 day at a time. It might peak. It might peak. Where it peaks and stops, don't worry. You carry on. You carry on. Don't look at the number too much. Don't pay too much attention to the number. Pay attention to what has to be done today. That would be much more important. Right? Let's not panic keeping the result, destiny. Let's more worry about the process. Don't worry too much about the destiny. Okay, yeah, destiny is taken care. You worry about the process. All right. Okay, how many of you have taken the mock yesterday? How many of you have taken the mock yesterday? Quick. Yeah, don't worry, I'm not asking the details which mock, what score later, but I'm very interested that how many of you have attempted mock yesterday. Mock cats. Any mock. Technically, you should have written during your time slot for cat. Mukesh, Rishti, Keval, Sonakshi is here. Good. Marshall is here. Isha, Rishabh, Sumit, Preet. Guys, there's only 8, 9, 10. Yeah. Others can drop from this particular lecture. Others can drop. So if you are not writing any mock, nothing doing, so why attend lecture? I'm seriously questioning it, right? I'm not saying that okay, you got to any mock for that matter. I'm not saying that this series only you should write. Any mock is fine, whatever you are following. I have all due respects to all the mocks, but you should be writing, not writing but attending lecture. Please drop from this particular lecture. I'm honestly telling you guys, because you will not go anywhere with that attitude, right? Yeah, that's my point. Okay. Shrikar, you joined just now, excused. But your name looks familiar, Shrikar. You were there some other day also. Anyway, it could be some other speaker, don't worry. Okay, okay, seriously, if somebody has not taken the mock, you will have obvious reasons. If the reason is stronger, really stronger than your goal, I'm fine. Otherwise, please consider how you go about it. You should be writing at least 3 mocks in a week, right? That's very important. Fine, guys, so let's get on to the lecture. So here we are not discuss up too much about the mock. I made my point. Let's go ahead and let's try and see how let's build a little bit of understanding about, let's do the reinforcement about the quadrilaterals today, more with quadrilaterals, and when we come tomorrow we will try and mix with the other questions. So most of the questions are with respect to the cat, but there are few questions that we need to be mindful about. I've removed answer choices, and here comes the question. Each question should be technically done about in a minute's time, but nevertheless I will give a little more time. All of you, take your book, take your pen. So sit with book and pen. Without book and pen, don't sit. If you think that no, I will sit without book and pen, please log off from this meeting. Doesn't make sense, right? So let's follow certain protocols. Let's not make any entertainment here. So education has a purpose and a meaning. So let's do it in a mindful manner. Go ahead. Yeah. Don't worry, Shrikar. Go ahead. Try and answer the question. We are dealing with quadrilaterals today for some time. There are certain important elements about quadrilaterals. As we discuss, we will bring forth all those views. By the time we do 4 or 5 questions, most of the points will surface. All right. So, okay, if I give a little more time, you will understand it. Yeah, so no worries. Good. So, you just wanted, some of you wanted a little more time to plug in the answer. So, you must be almost around the corner. Guys, first to start with, which are the 2 most important figures from the examiner's perspective on the quadrilaterals? One, parallelogram. First, let me make that point very clear. So, if I put the hierarchy and the order, parallelogram is very important for them. Trapezium is very important for them, because a lot of people tend to believe that rectangle is very important, square is very important. Sure, they are important as well, but from the test's perspective, if you take a look at the test perspective, your understanding of parallelogram and trapezium is what is much more important. Rectangle and squares are taken for granted. There is nothing much out there. We are all very comfortable right from the school days, because these are the figures that we see. But when you see from the CAT and the other exam perspective, let's be mindful that, hey, pay attention and try and revise, because I'm not revising the complete parallelogram trapezium type. Sure, so as we discuss, I will put forth those views and the points so that you are kind of clear there. Pay special attention to parallelogram and trapezium, very important. And therefore today also I'm going to talk little more about parallelogram and trapeziums there. Okay, in a parallelogram, couple of things even before I come to this particular question. Let's see, already in a parallelogram, what are a couple of things that I need to be little mindful about. We know that opposite angles are equal. If I say that, say this particular angle is x, this is also going to be x, and if I say that this angle is y, this is also going to be y. Okay, and we already know about the parallel sides. Naturally, opposite sides are equal in measure, but coming to the angle perspective, the opposite angles measure equal. Second thing is, adjacent angles are supplementary. These two together adds up to 180. These two together adds up to 180. Adjacent angles are supplementary. Opposite angles are equal. There are 2 words, opposite as well as adjacent. opposite angles are equal, adjacent angles are supplementary. Both words, all right, adjacent as well as opposite should tick in our mind. Okay, next part. Whatever be it, if I take an angular bisector of this, and if I take an angular bisector of this, the angular bisectors, they always meet and they produce a 90-degree angle. Whatever be the diagram, doesn't matter. Take any two adjacent sides. If you take any two adjacent sides and produce an angular bisector, they meet at right angles. What is this? Angular bisectors. These green lines are the angle bisectors. Why? Because this has become x by 2 and this particular angle has become y by 2. We know that x plus y is equal to 180 degrees. Therefore, x by 2 plus y by 2 is 90 degrees and hence they meet perpendicularly. Probably these are certain things that you should know. Third point, by joining the midpoints of the parallelogram, important because sometimes while finding certain things we might require this. If I join the midpoint of the sides of the parallelogram, that also gives me a parallelogram. By joining the midpoints of the sides of a parallelogram results in another parallelogram. What if I join the midpoints of this particular parallelogram? That again results in the parallelogram. That also results in the parallelogram. By keep joining the midpoints of the parallelogram, we get the parallelograms themselves. Again, it keeps generating the parallelograms. Fair enough. Probably these are some of the points the moment you may have to kind of keep at the top of your mind. Not just this, many more. So as we go along we will see, but at least on the face of it, these are the things you might have to consider. Fair enough. Let's take a look at this particular question. Let's quickly take a look at this particular question. Diagram might look something like this. Man, this is 30 degree and this is 30 degree. You may wonder how, because angle A is 60 degree. So bisect, because it's a bisector. So angle A is getting bisected, therefore 30 degree each. Therefore, I imply that adjacent angle. If angle A is 30 degree, then I know that angle B is nothing but, angle A is 60 degrees. Angle B is 120 degrees. I know that adjacent angles are supplementary, but this is the bisector, therefore 60 each. It's a bisector, therefore 60 each, right? And I also know that, hey, this particular angle is a 90-degree angle. So multiple ways to approach this. Hey, if I look at this part of the triangle, I got 30, 60, 90 triangle. That is one way of looking at this. And there are multiple ways of looking at this. Okay, you may say that, man, this is 120 degrees here. Therefore, this becomes 30 degrees here. That is one way of looking at this particular stuff. Okay, so you get a couple of angles. My point is that you have a 30, 60, 90 triangle. Here you have a 30, 30, 120 triangle. You may wonder, how do you know that? Because opposite angles are equal. If I know that when this is 60 degrees, this is 120 degrees. Therefore, if I consider only this part of the triangle, the remaining is nothing but another 30 degrees. Fair enough. So what is given to me? It is given to me that BC is 5. If BC is 5, then AD is also 5, which we know this. If this is 5, then this is also 5. You may wonder how that is 5, because two angles are equal. If the side opposite this angle is 5 by 5, then the side opposite another 30 degrees is also going to be 5. So therefore, I know that, hey, I immediately get this point saying that this is 5. Fair enough. So from there, already if I proceed from there, I already knew that this is 60. This is 60. Why? Opposite angles are equal, because when I knew that this is 60, the opposite angles are equal. Pretty simple, 60. Therefore, I say that this is another 60. This is another equilateral triangle. In an equilateral triangle, all sides are equal. Therefore, you get all sides, all angles. No big deal about it. I was only questioning about opposite sides are equal. In a parallelogram, opposite sides are equal. Adjacent sides are supplementary. I was just questioning these two premises. I was only just questioning on this particular question these two premises, because it's a heavy on angles. And hence I say that, okay, this is 7, right? Sorry, this is 7. This is 7. All are 7. I wrote 5. Sorry, this is 7 units. Therefore, it is 1:1. All comfortable, my friends? Clear? Clear? Everybody clear on this? Everybody clear? We were only using a premise where opposite angles are equal, adjacent angles are supplementary. Yep. Every mock, Vivek, what you are talking, in every mock you get binary logic questions? I don't think so. I don't think so. Okay, in between Vivek is typing saying that in every mock he is getting a binary logic. Which institute is that which is giving binary logic every time? Every time they cannot give. It doesn't make any sense. Maybe if you write 20 mocks, binary logic can come 4 times. 4 sets of binary mocks can be there in 20 mocks at the most. Okay, 4 to 6. If you want me to give a range, 4 to 6 can be a range, not more than this. When you solve 20 mocks, 20 into 5. When you solve 100 sets, binary logic should come 4 to 6 times. Please give a feedback to that institute. Yeah, I'm telling you. Seriously, I'm telling you, don't exaggerate anything. You don't have to exaggerate certain things. Binary logic is not that important. It is important. I'm not saying it is not important, but exaggeration about binary logic doesn't make sense. Anyway, that's on the lighter note. I'm continuing my journey with quadrilaterals. All right, so here we come. Another one. Go ahead, my friends, everyone. Yeah. Go ahead. Take a minute. Do it faster. Shouldn't take much time. Go ahead. Your favorite figures are here. Yeah. All right, good. So what is cyclic trapezium? What is cyclic trapezium? Cyclic trapezium is nothing but isosceles trapezium. Isosceles trapezium, right? Cyclic trapezium is nothing but isosceles trapezium. What are the things that comes to your mind when we talk about isosceles trapezium? Isosceles trapezium means these are lateral sides. We call them as the lateral sides. Opposite sides in a trapezium are parallel. Quickly, just to put it into the perspective what we are talking. So if I say that, hey, this is A, B, C, D, then I know that AB is parallel to CD. Now the other two sides are lateral sides. In an isosceles trapezium, all isosceles cyclic trapeziums will become isosceles trapeziums. I'm not saying that every isosceles trapezium is a cyclic trapezium. A cyclic trapezium is nothing but an isosceles trapezium. In an isosceles trapezium, we know that the length of the lateral sides are equal. The lateral sides would be equal in measure. That AD is equal to CB. The lateral measures are equal also. All right, that's the point there in the cyclic. Also in the cyclic trapezium, if this particular angle is x, this forms also angle x, which means one of the parallel sides angle with lateral sides make the same angle with one of the parallel sides. Both angles would be x. Similarly, the lateral sides would make a similar angle with another parallel side. Lateral sides with parallel side. So this is one of the parallel sides with the lateral sides makes the same angle called x. Similarly, another parallel side along with the lateral sides creates another angle called as y. They would be equal only in isosceles trapezium. With respect to the angles, this is what we know. Also, these angles x and y, they are supplementary. They add up to 180 degrees. These angles x and y form supplementary. It is not y plus y becomes supplementary. No. All right, now this one, lateral sides, angles between the laterals, between the parallel lines, that is always supplementary. Fair enough. This is all the kind of you got to kind of remember when it comes to isosceles trapezium. Little more are there. As we go along the journey, we will try and explore them. Not all at once may be required out here. So since author said that, hey, this is a cyclic trapezium, nothing but isosceles trapezium. These two lines are parallel. If that is 1, 2, 3, therefore I know that this is also going to be 1, 2, 3. If it is 1, 2, 3, I know it is 1, 2, 3. If that is 1, 2, 3, I know that, hey, these two angles are going to be supplementary, 180. All right, these two are going to be supplementary, and hence you say that, okay, this is nothing but 57. This is going to be 57 degrees, right? 123 and 57, which is 180, because we know that they are supplementary. Coming to this, hey, because it's a rectangle, it's also given that PQRS is a rectangle. I know that, hey, this whole thing is a right angle triangle. Out of right angle triangle, you have 57 as a part of this. Therefore, I have the deficit. This deficit is 90 minus 57, which is 33 degrees. Again, what are the points out here? In an isosceles trapezium, every cyclic trapezium is an isosceles trapezium in which the angle formed by the lateral angle between the lateral sides, that is nothing but lateral side, and the one of the parallel sides would be equal. Same thing happens with the other parallel side, but x and y are supplementary. Okay, that's the point there. Shall we proceed from here? Shall we proceed? Simple questions. Simple questions. But we can't ignore these concepts before we go deeper. Yep. All good? Shall we proceed? Yeah. Okay, that's nice. This is one of the beautiful cat questions. Yeah, one of the very, very good cat questions. I'll give sufficient time. Think about it. Yeah, wonderful. Wonderful. So everybody is gearing up. Very nice. Take sufficient time. There is absolutely no hurry. But crack this. Preet, what is that? Okay, you are getting that kind of number. Okay. Okay, that's the area. All right, no worries. Fine, guys, leave this. So I don't know whether are we disconnected, why some of you are taking this much time. Okay, let me ask you a question. Please answer this. Everybody, please answer this question. Let me ask you a question here. Everybody answer this particular question. It's a right angle triangle. In a right angle triangle, I have dropped a perpendicular onto the side AC. Let's say that ABC is a right angle triangle, right angled at B. Everybody answer this question first. Everybody answer this question. If I say that, hey, this is 9 units and this is 4 units. Let's say this point is called M. AM is 9 units, MC is 4 units. Can you guys tell me what is the value of BM? What is the measure of BM? Quick. Put in the chat. In few seconds, you should put this. In a right angle triangle ABC, right angled at B. From B, I dropped a perpendicular to hypotenuse AC. And I'm saying that AM is 9 units, MC is 4 units. What is the measure of BM? What is the measure of BM? Quickly answer this. What is the measure of BM? Guys, fast. Tell me what is BM? What is the measure of BM? Are you guys there lagging behind? What do you want to click on the live button and come to the live window? Click on the live and come to the live window. If you guys are lagging a little behind, is that why it's taking time? Right? Yeah. Okay. Yeah. So we discussed about this. If I'm not wrong, we kind of discussed about this while telling the right angles. I already made it a point. I said that, hey, consider this. We said this, right? So we said that AM, all it here, AM into all it now. I said AM into CM is also is equal to BM square. I said that using the similarity of triangles, we can arrive at this, right? So we can arrive at this AM into CM is also nothing but BM square. I also, along with this, I told you a few other things as well. Forget this, numbers are here. So I also said this, okay, here AB square, you take A as the parameter. A is one of the points. The point should be taken from on the, I told you, all right, how do you remember this? Take the critical points on the hypotenuse. A is one critical point. From A, you can write this, AB square. From A, what are the three dimensions? AB, AM and AC. AB square is also equal to AM into MC. Proofs come from similarity of triangles, okay? Then you say that on the hypotenuse, I will take M as the critical point. Then MA, MC, and then you have MB. You write this as MB square is also equal to MA into MC. Okay. Now the third critical point on the hypotenuse, third point on the hypotenuse C. From C you say that CM and CA is equal to CB square. That is CB square is equal to CM into CA. Alright, this is what you kind of write there. I told you to remember this. Had you just remembered this, right? So what the question that I asked, hey man, this is 9 units, this is 4 units, tell me what is this? You would have kind of plugged into this. MA is 9 units, MC is 4 units, which is nothing but MB square or BM square, both are same. Therefore you say that MB is equal to 6. Okay, why did I ask you to remind about this? Because that is the application, that is the concept, one of the concepts that I am going to use on this particular question. Let's take a look at this. How do we use this on this particular question? See, these reflex actions are important. Okay, yeah, let's take a look at this. First of all, in an isosceles triangle, forget these particular lines. Let's say for the time being, leave these lines. I don't want these lines. Let's say, hey, this is 20 units and this is 52 units. If I drop a perpendicular from S onto PQ, if I drop a perpendicular from R onto PQ, if I drop a perpendicular, so what happens? I am getting this as 20, but the total measurement was 52 and the remaining 32. So out of 52, 20 is here. Out of the remaining 32, because it's an isosceles trapezium, it gets split equally. This becomes 16 units and this side would become 60 unit. That's the breakup of this 52. 16 and 20 and 16. That is the first parameter. You can't say that, oh, I didn't even knew that. This is the common sense. This at least you would know based on this. And hence, let me rewrite this plan. Let me come back here. I will say that, let me call this particular point as X. Let's say this point was X here. So that is the point X I have. This is 16 units. All right. This particular area is going, that particular point is going to be 16 units. Good. So let's keep that. Therefore, what is the remaining one? The remaining is 20 plus 16, which is going to be 36 units. What was that? Hey, this whole stuff was 52. This was 52. So I kept this 16 on one side because I know that Px is 16. Then what is from X onwards till Q? 20 plus 16. 20 plus 16 is 36. Hey, give me a quick confirmation that so far you are clear. The breakup of 52 is clear, everybody. Breakup of 52 is clear. Quick. Respond. Breakup of 52 is clear. Are you clear with this 16 versus 36 at X? At X, X is the point. X is a perpendicular. Sx is the perpendicular to PQ. That is clear. 16 versus 36 is clear because my job is done the moment I realize that fact. Yeah, actually the job is over. This is the first job. Yeah, cool. Then the question is over now. All right, the question is over. Hey, why don't you look at this, man? All right, now why don't you look at this? All right, take a look at this. It's a right angle triangle. Which right angle triangle I'm talking about? This whole stuff. That's a right angle triangle. Which one? QSP here. QSP is a right angle triangle. Who said? Author only said. I'm not saying this. It's here. Hey, Q. All right, now if you come back here and take a look, QSP is a right angle triangle. Okay, in this particular right angle triangle, so I want the height. You may wonder why on earth you want the height, because to find the area of this trapezium I need the median. I got, that is the average of the two parallel sides is also called as the median. Average of two parallel sides is also called as the median of the trapezium. Fair enough, I got the median. Median into what I should do? Height I should do. Median into height gives me the area. So I am just deprived of height. Height is what is missing. So come back to this particular triangle. Hey, where is the height, man? Sx is the height. This Sx is the height. Now I apply the concept that I already learned. I'll say that, hey, I will take X as the critical point. Therefore, you say that XS whole square is equal to here, from here till here. Then you say that XP. You say xp into x cube, xp into x cube, right? Xp into x cube. This is what you kind of do, xp into x cube. Do I know xp value? 16, x cube value 36. Under root is what is my xs? Nothing but my height, all right, which is nothing but 4 into 6, which is 24. So 24 units is what I'm talking as the height. Come back, multiply this by 24 in place of height, make it as 24, you get the answer. No big concepts out here. Try to understand this. It was the figure which we kind of already analyzed. That right angle triangle was before only analyzed in one of the lectures. It was just an application how it is getting used, squeezed into your trapezium. Okay, yeah, I hope everybody is clear on this question. Everybody is clear on this question. One of the popular concept is getting squeezed into trapezium. That's it. That is it. That is all which is happening out here. Comfortable? Everybody comfortable with this thought? Good to go to the next one. Yeah. Yes. Guys, other than Chandni, Mukesh, Keval, okay, good. Sumit, Vibha, that's all right. Yeah, now at least better response here this time. Okay, cool. All right, let's go to the next one out here. Trapezium. I'm spending little time on trapezium. Go ahead. ABCD is a trapezium in which the sides AB and CD are parallel. Yeah, take a minute. Interpret this question. Yes, guys, this is a cat question. I only change the numbers. Okay, how many of you remember this concepts? Please take a look at this particular proof later. How many of you remember this particular concept, right? What is the concept I'm talking about, right? When you, any, for example, in any trapezium, listen to this, take a look at the proof. Maybe after the lecture we can prove it, but then we'll simply take some time. So let's quickly revise the things. So when you take a look, whenever, what is the concept here? If this area is A1, if this is A2, this also would be A2. Shape may be different, area remains same. I'll assume that this area of this triangle, I have the triangle there, right? We divided this into 4 triangles by using 2 diagonals. 4 triangles. So A1. So the area of this, if I say is A2, area of this also A2. You may say that shapes are looking different. Sure, shapes can be different, but the area is same, right? There are the proofs for it. Please take a look at that. Otherwise, we get into it, we'll simply take 8 to 10 minutes on that, right? A2. And if I say that this is A3, fair enough. So this A2 and this A2 would be equal. Leave that parameter for the time being. How these three are related, A1, A2, A3, they would be in GP, right? This A1, you may say that why not this A2, sir? Take one of the A2s, no? Don't take both the A2s, take one of the A2s. So A1, A2 and A3 are always in GP, geometric progression, in which A2 is geometric mean, because I said that A1, A2, A3 in that order are in geometric progression. Therefore, you say that A2 is the middle one, is nothing but the geometric mean. So now what is given to me? In this particular question, the mean is given to me. All right, geometric mean is 12. One of the values is given to me 8. I can find A3 therefore. All right, I can find A3. Let the value of A3 be X. Let's say that the value of A3 be X. Therefore, you say that, hey, 12 is nothing but under root of 8 into X. In other words, you say that 144 is equal to geometric mean, because A2 is nothing but the geometric mean. That's what you are trying to find. You say that a 144 is nothing but 8 times of X, and hence you say that X is equal to 18 units. 8 times 144. Fair enough. So therefore you say that, man, this is 18. So, and I already know that by virtue of this, if this is 12, this is also going to be 12. Add up all these particular pieces. You say that on one hand you have 8, other hand you have 12, then you have 18, then you have 12. Add 4 triangles. angles, which will become 50 square units. Okay, everybody clear about this? Everybody clear about this? They are in GP. Basically, you just have to remember that they are in GP, one of the very important concepts from your high school on the trapeziums. One of the important concepts on trapeziums. Of course, you guys would have proved it. In the high school, the proofs carry 5 marks for this. Yeah, and you may say that we have conveniently forgotten also. That's also true. You proved it, you forgot it. Both would have happened. Yeah, but now it's a time to recall it. Now it's time to recall. That's a point. Right? All the things that we are discussing, the high school you had proved. Your Pythagorean theorem also you should prove. Y square of the hypotenuse in a right angle triangle is the square of the other two legs. The proofs carry maximum marks. Where do you learn proofs? In the high school. In the high school. Yeah, cool. All right. Let's go further. Let's go further. Yeah, another beautiful cat question as it is. This is cat question word to word as it is. Letter to letter as it is. Go ahead. Another beautiful cat question on quadrilaterals. I removed answer options. Okay, I just removed answer options. There are options for all these questions. I just took off the options so that you think and write. Yeah. All right. So before we do, let me ask you a few questions, guys. Let me ask you a few questions just to be let's clear, and then we will proceed on to this particular question. By joining all at midpoints, if I join the midpoints, what is the resulting figure? If I join the midpoints, I want the resultant figure, right? Resultant figure. If I join the midpoints, because it might come, all right, it might come in some of the topics that we do. Okay. Midpoints of rhombus. Midpoint of rhombus. If I join the midpoint of the rhombus, what is the resulting figure? Put it in the chat. If I join the midpoints of a rhombus, what is my resulting figure? If I join the midpoints of the rhombus, what is my resulting figure? If I join the midpoints of the rhombus, take any rhombus in general, any rhombus, regular, irregular, whatever it is. If I take a rhombus, join the midpoints, what is the resultant figure? What is the resultant figure? Hey, these are important, all right, because we will calculate the areas based on geometric progressions by using these things, right? Yeah, so that is a rectangle, that's right, all right, rectangle. As Keval said, that forms a rectangle. If I join the midpoints of rectangle, midpoints of, all right, if I join the midpoints of a rectangle, what is the resulting figure? If I join the midpoints of a rectangle, what is the resulting figure? An important study from high school, guys. If I join the midpoints of a rectangle, what is the resulting figure? If I join the midpoints of a rectangle, what is the resulting figure? Rectangle is given, you join the midpoints, it becomes a rhombus. If you join the midpoints of a rectangle, the resulting big figure becomes a rhombus, right? Resulting figure becomes a rhombus. Okay, midpoints of a parallelogram is another parallelogram. Alright, midpoints of a parallelogram is a parallelogram. Midpoints of a rhombus is a rectangle. Midpoint of a rectangle is a rhombus. What is midpoint of squares? If I join the midpoints of a square, what do I get? Midpoints. If I join the midpoints of a square, what do I get? What is the resulting figure? If I join the midpoints of a square, what is the resulting figure? These are 100% results. What we are talking here are 100%, no matter what. What is the midpoints of a square? That becomes another square, right? That becomes another square. Not only that, now listen to me, everybody listen to me. Not only that, all right, when it comes to the square, not only that, okay, this figure can be something like this. What did I do? I maintained some ratio here, x is to y. I maintained some ratio on the sides. Whatever be the side AB, I took a point P, because author only said that, man, you take a point P in such a way that AP, all right, now in such a way that AP is less than PB. So therefore, I don't take a midpoint now. I am not taking a midpoint, because if I take a midpoint and form a square, the area of the square that is formed will be exactly half of that. That's a point there. Area formed will be exactly half. Assume that if this is my ABCD, which is a square, if I take the midpoint, if I say that P is the midpoint, Q is the midpoint, R is the midpoint, and S is the midpoint, and if I join this, the area of PQRS will be half of ABCD, but it has not become half of. Area of PQRS has not become half, it has become 5 by 8th of the original square. It has become 5 by 8th. Why? Because P is not at the center, Q is not at the center, they are not at the center. So, but then I have to form another square. The onus is to form another square. Man, you got to take PQRS in such a way that it ends up forming another square. It should end up forming another square. So what do I do on this? So therefore you realize that, hey, if you maintain a ratio of x is to y, take a mark a point Q here, maintain the same ratio, don't change the ratio. Hey, I maintain x and y here, then I will maintain z and w here. No, don't maintain a different ratio, maintain the same ratio, x is to y. Then go from C to D, maintain the similar ratio, x is to y. Then D to A, maintain the same ratio, x is to y. If you now join these points, it forms another square. It always forms another square. That is the concept. Maintain the same ratio, it forms another square. All right, now that's how we formed another square, PQRS, because the onus was on us to find that you got to form a square PQRS by choosing the points PQRS on these particular points. It was left to us. You decide where you want to choose, but when you choose, it should form another square. What is the concept that we should know? The concept is maintain the same ratio. If it is x is to y, maintain x is to y, maintain x is to y, maintain x is to y, you get another square. That square will have certain area. Fine. So how do we solve algebraically these kind of concepts? You always say that instead of taking two variable concept x and y, you say that, hey, if this is 1, it's a ratio. Ultimately, it's a ratio. 1 is to x. That is how you will take. You will call this as 1 is to x. This is the quicker way of solving an algebra. Basically, that's it. You may say that x is to y wrong. Absolutely nothing wrong. 1 is to x makes the problem solving faster. This is what you learn in algebra, because it's a ratio ultimately. You may say that, sir, AP you took it as 1, right? AP I took it as 1. I may get x as 7 by solid. I may get x as 7 divided by 3. Fair enough. If you get x as, because ultimately what is AP to PB? You said AP is 1, PB is x. There is an x here. If this is 1, what if you get x as 7 divided by 3? I'm just telling. Then the final answer is 3 is to 7. If it is 7 by 3, your final answer is going to be 3 is to 7. That is how you kind of write. But the point is what? Don't make two variables x and y. Rather, you make one side 1, another side x. Which side to make it as 1? That's your choice. You may say that, no sir, I will make this x and I will make this 1. Absolutely no problem. Which side you make it doesn't really make a difference there. But you know from algebra that one of them should be made 1, the other should be made x. Doesn't matter which one you make 1, which one you make x. Fair enough. So idea is what? Find this x. X can be fraction, x can be irrational, whatsoever it is. We will try and find this out. Okay, therefore what is the side PQ now? Side PQ, it's a right angle triangle. This side PQ I'm talking about. Let me first find out what is the side PQ. If I want to find the side PQ, you understand that this is under root of one leg is x, therefore x square. Another leg is 1, therefore 1 square. Okay, this is the side of the square. Therefore, what is the area? You are earlier, the side of PQ ABCD, the side of the square ABCD is 1 plus x. Side of the square ABCD is 1 plus x. Side of the square PQRS Side of the square PQRS is under root of 1 plus x square. Guys, give me a confirmation that we reached this place safely. We are all safe here. This portion we reached, this boxed portion we reached. You understood till there? You understood till there whatever I said? This box portion is clear. Give a quick confirmation. Is this box clear? The side of AB is 1 plus x. The side of AB is 1 plus x. And the side of square PQRS, side. I'm writing side. These are sides. These are not areas, sides. These are sides. We reached the side other than Rishav, Keval, Chandni, Ashutosh, Vibha and Chinmay. Can others also confirm that we reached the side safely? Sides are clear. This is a beautiful cat question. Simple one. We just have to know the concept clearly there. Sumit, Srishti, others. Is there somebody else? Still confusion there? Okay, Preet, Mukesh, very good guys. Okay, therefore let me write the area. Let me write the area. Area would be of the form 1 plus x whole square. And area would be of the form under root of 1 plus x square whole square, because area is a square function of the side. We know that already. We already kind of know that from our earlier study. Alright, similarity of triangles. I told you that similarity need not be only in triangles. Similarity can be in any geometry. Any geometry. We examined this in one of the hexagons also in previous lecture. Now we are examining the same thing on the squares. Side ratio I know. Therefore area would be a square function of this. Hey, what is this particular ratio? This particular ratio author says that as 8 by 5. You may say that, sir, it is 5 by 8. No, 5 by 8 is with respect to PQRS divided by ABCD. I wrote ABCD in the numerator, therefore I corresponded to 8 by 5. Resolve this particular issue. Let me resolve it. Therefore 1 plus x square plus 2x divided by 1 plus x square is also equal to 8 by 5. I am not doing anything. I am just solving this. I am just solving this. Okay, from here upon solving you get that 5 plus 5x square plus 10x is also equal to 8 plus 8x square. Upon solving you get that, hey, this is 3x square plus 3x square, 10x, 3x square minus 10x plus 3 is also equal to 0. From here you realize that the values are going to be 9 by 3 or it is going to be 1 by 3. 9 by 3 or 1 by 3, which implies that the value of x can be either 3 or 1 by 3. Good, I am getting two values. X can be either 3 or 1 by 3, but I know that x has to be greater than 1. X has to be greater than 1. I will take the value of x is equal to 3. Who said? Author only said AP has to be less than PB. Therefore I will not take 1 by 3, although I got one of the values as 1 by 3. I won't take that, rather I will take it as 3 and I will come back and plug this particular number 3. My answer becomes 1 by 3. Comfortable? Everybody comfortable? Solving should not be a problem. Solving should not be a problem. The concepts reaching this particular place has a tremendously good concept there. Wonderful, impactful concept comes here. That concept should be clear. Rest is incidental. Rest is incidental. Similarity, etc. is incidental. All good? All good? Anybody, any questions? Let me know. Otherwise, we'll push to the next question. All good so far? Yeah, bit of algebra coming into this. Yep. Let's push to the next one. Try this question. Keval, this is the trick. Whenever the ratios come, okay, we don't use the two variable concept. What I was saying is it's a two variable versus one variable. Two variable versus one variable, which is the profound algebra concept. It is a profound algebra concept which we use in ratios. It's a profound in the sense it saves time. All right, it becomes faster. Instead of two variable, if I have only one variable, it's a question of two variable versus one variable. See, I could have rather written this as x is to y. I could have written this as the side AB is P divide side AB in the ratio x is to y. That is fine. I will finally get my answer as x by y. That's a two variable concept. What is one variable concept? Make one of them 1 and just use another variable. That's it. Okay, if we already used x and y, use another variable called as k. K is to 1. Alright, k is to 1. That's it. So one variable concept gives the answer faster. Two variable concept might take extra 30 seconds. That's it. Clear there? It's a algebraic technique. Whenever the ratios are questioned, instead of using two variables, we use one variable. That's it. It's a technique, algebra method. Hey, can I use two variables? You can. You will take little more time. That's it. You would have taken 30 seconds. Should we do by using two variables, Keval? We will do it. You want me to do? We will do it right away. It will take 1 minute for me to explain. You can also do. What big deal about it? Hey, it will take only 20-30 seconds extra, man. No, not but when exactly. Exactly means what? Ratio. I'm telling you, right? Whenever ratio is questioned, we use this technique. Hey, in algebra itself, directly such questions come, Keval. This is via geometry we are discussing this. In algebra only directly such questions come. Yep. So whenever ratio is questioned, and the moment you find a ratio, that is when you can convert a two variable to one variable, probably to save 30 seconds. That's it. Otherwise, what is the cost? Cost is 30 seconds. That's okay, yeah. That's okay. As long as you are comfortable, that's okay. No big deal about it. No big deal. I just made it a point. That's it. I just made it a point that one variable comes there, because usually people take the two variable and they will solve. That's it. Nothing wrong. I took this point for granted. Two variable concept I took for granted. Okay, we all do that. I just thought that, hey, there is this one also, one variable concept also. I just thought of introducing this along with this question. That's it. I just thought of introducing it. Otherwise, usual what? Usually 75% of them use this. Or let use two variable concept. 75% use this. Nothing wrong about it. Nothing wrong about it. Convinced? Clear, Keval? I want me to solve, I will solve. Don't panic. Nothing there. Yeah? Clear. Nice. All right. So here we go to the next one. Quick, guys. Couple more questions. Go ahead. 1 minute should be a good time. Yeah, guys, this is one of the popular theorems with respect to cyclic quadrilateral. I hope the font was visible. I'm not sure if some of you guys have struggled with this. I think the font was very different here. In a cyclic quadrilateral, or at the other side, when all the sides are given, that relationship between the sides and diagonals. What I was trying to ask here, the relationship between sides and diagonals. We connected by using the Ptolemy's theorem, right? Ptolemy. I think this is the name of the mathematician. This is what we connected by using the Ptolemy's theorem. What is that? This is true only in cyclic quadrilateral. All right. So let's say that this is a cyclic quadrilateral. Say whatever was given to us. Okay, don't go by exact sizes here. I'm just drawing a symbolic diagram. Say this is a cyclic quadrilateral ABCD. Some cyclic quadrilateral. If this particular side is X and the opposite side is Y, and another side here is P and the opposite side is Q, then I have the diagonals D1 and D2. Let's say the two diagonals, diagonal 1 and there is a diagonal 2. Product of the diagonals, say that the diagonals are D1 and D2. Product of the diagonals is nothing but sum of the product of opposite sides. Product of the diagonals is nothing but sum of the product of the opposite side, that is X into Y. You write this as X into Y, and then you also take the P and Q. Alright, this is the product of the diagonals is nothing but sum of the product of the opposite sides. True only in cyclic quadrilateral. Had you understood this particular one, you could say that, man, this is X, this is Y, sorry, this is opposite side. This would be y here, and this would become p here, and this would become q here. P and q, opposite sides, because when you put them together in that particular order, so x, and then there is a p, and there is a y, and there is a q. Therefore, you would have multiplied these two, which could have become 20 root 10. So x and y is nothing but 20 root 10. Then you had p and q. Alright, you had this p and q. When you multiply them, that could have become 10 root 10. This is what you have, which is equal to product of two diagonals. One of the diagonals is 3 root 10. Therefore, the other diagonal is nothing but 10 units. Other diagonal simply becomes 10 units. So if you knew the Ptolemy's theorem, this is lot more easier. Okay. Yes, what is that you are trying to ask? Should the sum of opposite side be same in a cyclic quadrilateral? No, Abhinav, nothing like that. Cyclic quadrilateral means what? You should be able to put that quadrilateral circle should be able to circumscribe or inscribe the quadrilateral in a circle. That's it. No hard and fast rule there. All right. Yeah. Not inscribe. Inscribe the quadrilateral in a circle or circumscribe. The circle has to be around the quadrilateral. That is cyclic quadrilateral. Alright, yeah, Ptolemy's theorem is what we are talking about. One of the important theorems with respect to cyclic quadrilateral. Just remember that particular point. Okay. Here comes a beautiful cat question. Yeah, quadrilateral study by and large done. Go here. Let's go ahead. Yeah, cat question as it is, word to word. Cat question as it is, word to word. Okay, go ahead, resolve this. What happened? You guys wanted more time on this? All concepts are kind of known. Okay, listen guys, listen, let's do this together. Look at this. All right, now first look at triangle AEC. Look at triangle AEC. First look at that outer diagram. Everybody quickly do it with me. Look at the triangle AEC. 45, therefore I know this is 90, right? Therefore I know that this is 90. Immediate reaction, 45, 90. Take a look at the triangle AEC. You know that two angles are 45 each. Therefore I know that angle E is 90. First response of the mind. Fair enough. Then take a look at this cyclic quadrilateral, this portion. This is the cyclic quadrilateral. Which is cyclic quadrilateral? AEDB is the cyclic quadrilateral. AEDB is a cyclic. That's the reason I'm bringing now. So circles we finished, triangles we finished, kind of quadrilaterals also we finished. Kind of. Okay, whatever more important things we should try and keep a look, we kind of took a look. So therefore we are now ready for our race. Entire race we are kind of ready. That's what we are kind of trying to do out here. Okay, look at the cyclic quadrilateral. In a cyclic quadrilateral, given this is 90, therefore this is also 90. Therefore angle B also is becoming 90 there, because it's a cyclic quadrilateral. In a cyclic quadrilateral, opposite angles are supplementary. Opposite angles are supplementary in the sense, hey, these two would add up to be 180. Similarly, these two would add up to be 180, whatsoever it is. That's a point there. Okay, so if it is a right angle triangle, their angle B, that is 90, then I know that, hey, this is also 90. Therefore this becomes 45. Now focus on the triangle. C, D and B. Just check at CB, CDB. Yeah, I knew that this was 90. 90, 45 is the triangle in which BD is equal to 5 units. Then BC is also 5 units. And DC is equal to 5 root 2 units. Why? It's a 45, 90 triangle. Guys, are you with me so far? Are you with me so far? We had a triangle, we had a cyclic quadrilateral, all that stuff. Now we can mix and match all the things. Are you with me so far? Did we reach this 5, 5, 5 root 2? Did we reach? Have we reached this place? Everybody, from triangle to the cyclic quadrilateral to 45, 45, 90 triangle to get the sides as 5, 5, 5 root 2. Yep. Beautiful, wonderful. Yeah. Okay, we reached this place 5 root 2. Now it's also given that D is 6 root 2. D is 6 root 2. Therefore, what is this entire length? This entire length is nothing but 11 root 2. This entire length is nothing but 11 root 2. Great. Now go back and take a look at this particular triangle. Which triangle? Go back and take a look at the triangle AEC. In a AEC triangle, the side opposite 45 is 11 root 2. Then side opposite 90. Which is side opposite 90? From here till here. It is going to be 11 root 2 times of root 2. That is root 2 times of 11 root 2. Root 2 times of 11 root 2 is 22. Out of 22, I have 5 on this particular side. Therefore, how much I will have on the other side? 17. That is AB is equal to 17. That is my answer. Find the length of AB, which is nothing but 17 units. Are you all with me, guys? Clear? Clear? Everybody clear? Everybody clear about this? Basically, we were using the precept of 45, 45, 90 triangle along with cyclic quadrilateral. That's it. These were the things which were involved here along with the cyclic quadrilateral. 45, 45, 90 with cyclic quadrilateral. Should I repeat or you got it? Should I repeat this or you got this? Everybody got this? Got it? Yeah. Yeah. Hereafter, we are ready to consider all of them. The next lecture will have all of it. Quadrilateral, circle, triangle, because I kind of built all the elements there. Triangles we discussed in some lectures. Circle we spent one lecture. Quadrilateral we kind of spent some time today to orient ourselves. Now with the orientation is done. So now it's all mix and match. All right, little bit of problem solving in the next lecture. Okay, one more question. Take a look at this beautiful cat question as it is, word to word. Answer options removed. That's it. Only thing that I removed is answer options. Shrikar, which 45, 45, 90 you want me to brief? Where you reached? You want me to brief again? Where you reached here? This part did you reach? Yeah, did you reach this particular part? You mean to say you were here? This part did you reach? This particular triangle 5, 5, 5 root 2. This 5 is given. Therefore, I wrote this 5 and 5 root 2. Is that clear? After this, it's a given. It is also given. It is also given that DE is 6 root 2. It is also given that DE is 6 root 2. DE is 6 root 2 and EC is 5 root 2. Therefore, what is the full length? 11 root 2. All right, this is 11 root 2, right? If it is 11 root 2, now consider the triangle AEC. Now look at the triangle AEC. You got to look at A here, E here and C here. Forget the other parameters. Look at the triangle AEC. Forget others. Others doesn't matter to us. All this doesn't matter. Just look at AEC. AEC is another 45, 45, 90 triangle. Side opposite 45 is 11 root 2. Therefore, what will be the side opposite 90? What do you mean by side opposite 90 till here? Side opposite 90 will be root 2 times of 11 root 2. So which would be 22. Out of this 22, 5 is this particular piece. Therefore, this particular piece is 17. What is piece? Which piece I am talking? AB piece. AB is 17 because BC is already known as 5. Clear? Good. That's the point there. All right, guys. Here we go. Try this. Everybody try this. A minute is a good time for it. Quick. Okay, all right, do it with me. No worries. If I give a little more time, you guys will crack it. No worries on this. Okay, first let me quickly talk a little bit about common chord. Let me quickly talk because there is a word there. Let me talk about common chord. When will the common chord come in the picture? Listen, guys, everybody listen. That's all right. When will the common chord come in the picture? Whenever two circles intersect. Whenever two circles intersect. Big, small, doesn't matter. Whatever be that, right? Yeah, two equal circles, unequal circle, doesn't matter. Whenever two circles intersect, we get that phenomena of common chord. All right, this becomes a common chord. There will be only one chord which is common. You may say that, sir, I will draw a chord here. If you draw a chord here, it will be in circle 1. It will not be a part of circle 2. That chord does not belong to circle 2. You may say that, sir, I will draw a chord like this. It will belong to circle 1, but that does not belong to circle 2 because this particular line AB is not a chord to this. Only one common chord can be drawn. Whenever two circles intersect, only one common chord be drawn. Let me call this as AB. Let AB be the common chord. Okay, center of the circle. Let's say this is O1 is the center of the first circle. O2 is the center of the second circle. Now what it does, the line joining the centers, listen to this carefully. Line joining the centers divides the common chord. This is very important property based on which some questions would be created. Okay, this question is very simple one. This is not built on that. Line joining the common chord, line joining the centers divides the common chord, bisects the common chord orthogonally. Bisects, let me call this point as M. What I'm trying to say is, hey, AM is also equal to MB. Maybe in the next class we will see some examples built on this particular concept. Let's keep this word common chord. Common chord is whenever two circles intersect, only one common chord can be drawn. There is only one common chord which will be possible, and lines joining the centers divide the common chord orthogonally 90 degree. Bisects, it bisects the common chord. Now common chord does not bisect. Now don't prove that, hey, AB common chord will bisect the line joining the centers. Hey man, these lines are going. No, that need not be. That can be possible only if the circles are equal, right? It's not the other way around. Other way around is not necessarily true. What is true is line joining the centers bisects the common chord orthogonally. Based on that, some beautiful CAT questions were presented. We will see it in the next class. We'll see it in the next class. Okay, coming to this, what is that I want to put a thought. In the next class, we'll explore this particular thought. Sometimes you may have to reorient the figure, adjust. You got to learn to reorient this particular figure. Hey, what do you mean by reorient this particular figure? Let's first take a look at this. Hey, what is given to me? AC is the diameter, passes through the center. Say O1 is the center of the first circle. If AC passes through the center, then this is 90 degrees. Why? All right, now focus only on this circle, man. Focus only on this particular circle. Forget the other circle now. Oh, solid. Forget only this red. Look at only the circle on which I marked it. AC is the diameter. If AC is the diameter, then this angle, this particular one is nothing but the angle formed in the semicircle. This is the angle formed in the semicircle, which will be 90 degrees. You may say that, sir, what if I draw on this particular side? That is also 90 degree. Angle formed in the semicircle is 90 degree. Fair enough. That is one parameter. Second one, hey, look at this side now. Take a look at this particular side. Let's come to the other side of the circle. Let's come to other side of the circle. Author said that BD is also diameter. Good. Therefore, it passes through the center. If BD is the diameter, it passes through the center. Then this is the angle in the semicircle. See, all right, that becomes angle in the semicircle, which is 90 degree. Guys, these 90 degrees are clear now. These two 90 degrees are clear. Will you quickly confirm? Or these 90 degree angles marking is clear? Because they are the angles in the semicircle for each of those particular triangles. One of them is in the angle in the semicircle of the red circle. The other one is the angle in the semicircle of the green circle. Clear? Clear? Those 90 degree markings are clear. That is very important. The diameter should send the trigger of 90 degree. It should have triggered that thought. It should trigger that particular thought. Okay, good, fantastic. At least 10 of you said that it is clear to you. Very nice. Now what I do is, hey, why don't I align this? So now look at this. Can I bring this CD down here? Can I bring this CD down here? Yeah, you can draw a line parallel to this. There is a CD line here, bring it down because it's anyway 90 degree. Hey, you have a figure like this, my friends. Take a look at this. This is the figure you have, right? This is the figure you have. Here is my point A, here is my point B, which makes 90 degree. Here is my point C and here is my point D. Just take a look at this line diagram. This is all the diagram you have. If I want to just bring this diagram forth, highlight this particular diagram, this is all it is. AB, then I have BC, then I have CD. It looks like this. This is 8 units, this is 5 units, this is 4 units. Let me reorient this. Can I write this particular diagram something like this? So can I change this particular diagram to like this, which means A is here, D remains to be here. Alright, then I will say that I will bring this point as a D dash. Where is that particular D dash? Here. I will just bring it down and call this particular point as a D dash. Therefore, from A to D dash, what is the measurement? A to D dash, it's 8 plus 4. There is 8 here. This 4, I can bring it down here. Therefore, 8 plus 4. Okay, what about this one? This 5, you can shift it here. Therefore, it is 5. And hence, it becomes a Pythagorean triplet. 8 plus 4 is 12 units. This is 5 units. Therefore, AD is equal to 13 units, which is nothing but your answer. What was important here? Angle in the semicircle was important. You should have got these 90 degrees to start with. That is the point. Once you got this, you got to just realign the diagram. But without this 90 degree, God would have helped you. Nobody would have helped you, right? That is not possible. Once you get this, the realignment comes in the picture. Comfortable? All comfortable with the answer 13? Clear? Should I explain any part? Let me know quick. All good otherwise? All good? Confirm guys, quick. I'm waiting. 13 as the answer is clear. Okay, Rishabh, you are asking that can't we make use of the bisector of this? Okay, then do what? That is my question. Even if you use that, okay. So what you are trying to say is I will connect these two. I will connect these two parts and I will write this as 2.5 and I will write this as 2.5. You are trying to say this is 2.5, this is 2.5. And then what do we do? And then what do we do? How do you use this 4? How do you use this 4? There is a 4 here, there is a 2.5 here. So what do I do with this? What do I do with this? That's a point there, because when you drop this particular line, when you drop this, so is it necessary that it should go along this particular point? Nothing. Okay, Rishabh, making sense? Getting that angle in the semicircle was the concept here, man, Rishabh. Angle in the semicircle was the concept. It is not about bisecting that particular common chord. It was not about bisecting the common chord. Not about bisecting the common chord. Right? Check it out. Check it out. Will it become 13? Check it out. Becomes 13. Yes. Yeah. All right, Ritik, I'm not sure whether it came there. This is the CAT question as it is. It came in some other exams also, sure. In many exams it will come. All right, guys, I think let's kind of, it's already 8, 11, 20. All right, we kind of close it here. Let me quickly do a couple of announcements and we are kind of done. Okay, there is one free test left from the Unacademy perspective. There were free mocks. 3 of the mocks are done. There is one free mock scheduled on 7th November, 12:30 to 2:30. If any of your timings match with this, try and take this particular exam. Okay, try and take this particular test. Otherwise, you guys can continue with whatever you are doing, but on every Sundays do it. Hey, some of you are posting the doubts, etc. If you have the doubts, guys, please grab it. All right, just go ahead. Ask a doubt feature is there on the dashboard. All right, in case, all right, no, so some of your concerns are not getting addressed, use this. Ask a doubt. Ask a doubt. It's one of the free features provided. Ask a doubt. So click on that. It is a self-navigating one. So you just click that particular word, whatever the material that you are reading, just click it and then proceed. All right, you will be some answer you will get as soon as you could. Sometimes the video answer, written answers, you would get them, right? Yeah, so try that out. If you, because last 1 month you definitely get a lot of doubts from your mocks during revision. Use that up. Okay, yeah, if you like the video, so go ahead, like the video before you leave the lecture. You can share it. Your liking can be done offline also, online, offline, whatever the line that you are doing. If you like it, leave that mark as like it there. Subscribe to the Cat Ninjas so that whenever we are doing a lecture, you will get to know. Tomorrow night again we will meet at 10 p.m. 10 p.m. tomorrow night we will meet and we will do another lecture on geometry, and then probably we will do one of the important mensurations with respect to CAT perspective. Time be already one more lecture on geometry, and we will see if further lectures are required. Otherwise we will shift our attention to mensuration. That's pretty much about today. I hope all of you learned something. Some good revision has happened from today's lecture. I'm hoping that. Okay, I will see you guys maybe tomorrow night at 10 p.m. So bye till then, stay blessed. God bless you guys. So any concerns, quickly put it in the chat. I will probably wait for a minute or so. Thanks for being here. So good night to all of you. If there is any concern, you can put it out here. Tomorrow all composition, Ashutosh. All basics are done. Basic revision is done. Composition. We will mix and match. All right, Rishabh. Okay. Yeah, that's required, right? That's required for both me and you, the timing. Yeah. Yeah. Otherwise, I will also run out of time sometimes. Yeah. Good thought. Also, it pushes you, as you said. That's right. Okay, fine then. I'm signing off. Good night. I'm signing off, guys. I'm not finding any questions. I'm signing off. Good night. See you tomorrow night.